So we really are diving into the make piece of the supply chain, and lots of our supply chain management majors really enjoy getting into this part of the supply chain because it is action packed. There are new things, new challenges every day, a lot of problem solving with other people, a lot of being on your feet and getting out in the middle of where work is actually happening, seeing how that work is happening and solving problems there, enabling the company to be able to deliver value to the customer. So here's a little insight into what it might be like to work in the make piece of supply chain.
I think one of the coolest parts about being here is every manager I've had has encouraged me to reach out to other areas, learn different positions. You're not in your own little silo. You're out there, you're working with other people, you're working with other departments, you're learning more about what's going on in the business. My name is Eric Poley, and I'm a process manager at the distribution center. So supply chain's a pretty broad topic. There's a lot of different areas to it, but it's essentially how we get product and how we get that out to the customer. If you're sending out Gatorade, for example, and it's getting damaged on the way to the customer, you hear about that from the customer, and then you also get to come up with a plan with how you're gonna fix that. How are we gonna ship that stuff better? I'm usually getting to the distribution center around 10 o'clock in the morning. A lot of the things that I'm primarily concerned with on a day-to-day basis, especially in the morning, is figuring out how much volume we anticipate to have for that day, and then also what's my staffing situation. You know, there's my department, there's like 4 or 5 other departments that are operating simultaneously throughout the day. So it's reaching out to some of my peers saying, hey, you know, how are you guys looking today? What's going on with your staffing? What kind of adjustments can we make so we're all on the same page? You know, there's a lot of younger people here at the company, a lot of people in their early 20s, late 20s, but then there's also a lot of people that have been with the company for 25, 30, 35 years. And even though there's that gap, I mean, people are still kind of on the same page with just here, here to have a good time, here to be friends, and here to help each other.
This is my buddy Sean. He's another process manager here in the DC, so we're peers here. He's in charge of machine picking.
The relationships I've made, probably one of the best aspects of the position. Even though we've kind of all went on to different areas of the department, we're still good buddies and we still all hang out regularly.
So here we've got the infamous softball team pictures here. So here's our champs last weekend. That's Maurice right there. He's a semi-pro athlete. A lot of the guys at the DC, especially, very sports related. We're in a lot of different leagues that we play. Softball, basketball, football on the weekends. So this is pretty much a Saturday morning ritual for us. Get up, get to run a little bit, and get our workout in before we start the day. We're always having Granger outings. We're always having softball parties. We're having trips to Cubs games. So very sports related, very fun. And everybody is kind of on the same page with stuff. No one's really above anybody else. Managers are playing with associates, and you don't even really think twice about it. That's just kind of the way it is. Everybody's on the same team, and that's how people feel about it. Supply chain is this massive kind of theory, massive kind of set of ideas. So you can't just be doing one thing. You can get out there and learn other things. And to have managers that support that, and to have people that I could come back to and say, hey, you know, here's kind of what I'm thinking about doing, here's something I would like to explore, and have somebody who says, hey, you know, I can help you get to that level, or here's some things to think about, and just some guidance and some mentorship, really kind of makes me feel like, hey, the opportunities are out there for me to kind of do whatever I want to do here at Granger. I've got the support to do that.
So in the make piece of the supply chain, there is a lot of coordination of activities that needs to happen. There are so many different moving parts in our organizations, handoffs that need to happen, collaborations that need to happen, that it's very important that we schedule all of these activities, that we have a plan for scheduling these activities so that the work gets done. So that's what we're going to be discussing today, is some of the mechanisms for scheduling that we have in the make piece of the supply chain. So as a reminder to you, the only calculations that you will be responsible for on our exams are the ones that we do on these video lectures. And these calculations, there will also be lots of practice problems in the practice problems section of Blackboard to help you be prepared for the exam. Now in the textbook, there are many other calculations, but those will not necessarily be covered on the exam. Only the ones that we are covering on these video lectures. Anytime that you want kind of a list of the calculations or the topics that will be covered and won't be covered on the exam, you can always look at the exam review sheets. The exam review sheet gives a detailed listing of the topics that are covered and are not covered on the exam. All right, well, so let's get started. So when we were discussing the plan part of supply chain, we talked about sales and operations planning, S&OP, where we give a general overview of what it is, the overall capacity that we need in our organization to make large groups of products in our manufacturing operations. After we do this sales and operations planning, we're going to collaborate with sales, and we are going to do master scheduling. So master scheduling is where we're going to schedule out what are the individual, very detailed, specific products that we need to make, and when do those need to be produced? When do those need to be ready? So we'll create that master schedule. We're then going to use a calculation that's called MRP, Material Requirements Planning. Now, in this class, we're going to be doing some basic calculations regarding MRP. It's important for you to understand how those basic calculations happen. But MRP is going to give us two pieces of information that we need to be able to run our companies. It's going to tell us what we need to buy and what we need to make. So we have a master schedule. The master schedule is the detailed list of all of the very specific products that we need to make and when they need to be produced, when they need to be ready. Then we do an MRP calculation, and the MRP calculation will tell us what we need to buy, what materials we need to buy from suppliers, and when we need to buy them, and what we need to produce in our factory and when we need to produce it. So this is very valuable information for us. So we're going to use this term master scheduling throughout today's class, and the master schedule is the detailed list of all of the various products that we are going to be making and exactly when they're going to be produced. We're going to have an overall master schedule. Every function, every department in our organization will also have a master schedule, which tells exactly what it is that they're going to be doing on what days and at what times. This is very difficult in complex organizations. We need to coordinate the production of typically thousands of different configurations of products. So we certainly use software to be able to create this master schedule. And when we're doing this, we're going to use Excel business modeling skills. These are skills that you learn in SCM 4330, the business modeling class. We're going to use those skills to create a master schedule that enables us to maximize our performance in our organization. So we're going to try to maximize the labor and equipment utilization. So make sure that we have people that are being used and that we have our equipment is being used. Minimize our overall cost. Ensure that we have finished goods inventories to be able to fill those customer orders. And the very difficult thing is trying to match our production rate with our demand rate. And actually, we have a class in supply chain management that is called Supply and Demand Integration, where we talk specifically about how to create master schedules that are designed to match our capacity with our demand. So there are several components to the master schedule record. So let's go through each one of these. It's important that you know the definitions of these terms. So first is the forecasted demand. So this is not real demand. This is what we are predicting the demand will be at some point in the future. And this is based upon forecasting calculations that we've done previously. Then we have booked orders. So booked orders, this comes from sales. So those of you that are going to be in sales roles in organizations, your customers are going to place orders for particular products, and they are going to expect them to be delivered on certain days in the future. Those are booked orders. And so we have those booked orders scheduled so that we know that we need to fulfill those booked orders on particular days. We'll have projected inventory levels. So based upon what we currently have in inventory, what we plan to produce, and what we plan to sell or what we plan to ship to customers, we will have projected inventory levels so that we can look into the future and forecast how much inventory we will have at various points in time. Production quantities they come from the master production schedule, and this is the exact quantity of specific products that we're going to be making at a certain time. And then we're going to have something that's called available to promise. And I think it might be easier to talk about this coming up in a couple of slides. But available to promise is a calculation that we use in supply chain. We give that number to sales to let them know what quantities they can confidently sell, knowing that we're going to be able to fulfill that demand. So it's really available to promise as a calculation we do in supply chain, but it is a tool for folks in sales roles, so that as they're talking with customers and as they are accepting orders from customers, they can know what quantities of orders that they can accept, where we in manufacturing can confidently be able to produce those and get those to the customer. So we're going to perform these calculations on a rolling planning horizon. So what we're going to do is our companies will select a planning horizon where we're going to create this master production schedule, and we're going to be estimating inventory levels, and that might be a few months in advance, it might be a few weeks in advance, where we are creating this plan for what we anticipate doing. That plan then will get updated. So for instance, we may update that daily, we may update it every week, where we're looking at a planning horizon, say 6 or 8 weeks in advance, and then after the next week we look another 6 or 8 weeks in advance. So we're constantly updating the schedule, making sure that it's up to date with what is really going on in our organization regarding our production, our inventory, and our customer demand. So the first calculation we're going to do is projected ending inventory. So this is where we are predicting at some time in the future how much inventory of a particular item that we will have. Here's the formula, and this formula will be given to you on the exam. You just need to know how to use it, and I'm going to show you how to use it right now. But I want to show you, you've got all the definitions of the different terms that are there here on this slide. I want to demonstrate for you how this formula is used using a really simple example. Hopefully it's something that you can relate to. Obviously you wouldn't use this formula for managing, say, your groceries, but let's talk through an example maybe that you can connect with. So maybe you would like to know how many eggs. Maybe you eat eggs in the morning, you make eggs, and we're going to say that you make eggs for your little brother. Okay, so let's say you have a little brother and you're going to make eggs for your little brother in the mornings, and you would like to know, how many eggs will I have tomorrow? I want to know, how many eggs will I have tomorrow? Okay, so that's the question we're asking. So that's that first term there, EI sub t. That's saying, how many eggs will I have tomorrow? Okay, and so now I want you to write down some of these numbers so that because you can do this calculation. So let's say that you look in the refrigerator and right now you have 6 eggs. Okay, so that is your current ending inventory. So that's EI sub t minus 1. That's that first term there. You have 6 eggs on hand currently. Now, you plan on going to the grocery store and picking up 1 dozen eggs later today. So that is your master production schedule. That's what you plan to produce today. You plan to produce 12 more eggs. You plan to buy 12 more eggs. All right, so far we have that you have 6 and you're going to pick up 12 more. Next, let's say that your brother usually eats 3 eggs in the morning. Usually eats 3 eggs. So, it's like for the past several days, you've gotten up and said, okay, little brother, how many eggs do you want? And your brother said, I want 3, I want 3, I want 3, I want 3. So how many eggs do you think that your little brother is going to be eating today? Well, you might say, I think he'll probably eat 3, because that's what he's eaten in the past. So 3 is your forecast. Okay, 3 is your forecast. That's the term F sub t. But let's say that your little brother is actually sitting there right in front of you and saying, you know what, today I want 4 eggs. All right, so 4 eggs, that's your actual demand. That's your actual booked orders. Real order from a real customer is 4 eggs. So how many eggs will you have tomorrow? Well, you have 6 now, so that's 6. You're going to buy 12 more later today, so that's 18. And your brother is going to be eating 4 right now because that's a booked order. So you're going to pick the bigger, the max of the forecast or the booked orders. So your brother's going to eat 4, and so your ending inventory tomorrow should be 14. The amount that you'll have at the end of the day today or the beginning of the day tomorrow will be 14. And that's really how this formula works. So let's look at this in a problem that's similar to ones that you might see on the exam. All right, so here is our first example problem. This is similar to something that you might see on the exam. We have a planning horizon here for the next few weeks. It's currently week 16. And we need to project what our ending inventory will be in week 17, 18, 19, 20, and 21. So we're going to use the formula that you see printed on the slide to be able to do this. It's got all the information that we need. The first line there at the top is forecasted demand. So that is not real demand. That is what we had forecasted the demand would be. Sometime in the past, we had forecasted this into the future, and that is those numbers are those forecasted numbers. We actually have real booked orders. So these are real orders from real customers. They placed it with our sales area, sales professionals, and now those orders are on the books, and we need to produce those to be able to send those to those customers. We have the master production schedule. So the master production schedule is the quantity of products that we plan to produce and in what weeks. Now, this might look unusual to you. We have 250 in week 17 and then 0 in week 18 and 19. And you might say, well, does that mean that our production facility is shut down during week 18 or 19? And the answer is no. This matrix represents one product configuration. So you keep in mind our companies will have thousands of different SKUs, thousands of different individual products that we produce, and we are scheduling when we produce each of those different configurations of product. This is the schedule for just one configuration of product. So during week 17, there are probably dozens of other products that are being produced. During weeks 18 and 19, we are not producing this particular item, but the plant will be busy building all kinds of different other products that we produce, that our company produces. So let's take a look at our ending inventory. So first, we're going to calculate the ending inventory in week 17. And so here's how the calculation works. We look at our current ending inventory. So that's our ending inventory in week 16. So 50. Then the formula says plus the master production schedule. So the master production schedule for week 17 is 250. So 50 that we currently have plus 250 that we're going to be producing in week 17 minus the maximum of the forecasted demand or the booked orders that we have in week 17. So we need to be able to meet the needs of the bigger of the two numbers, forecasted demand or booked orders. So in week 17, forecasted demand is 80, booked orders is 90. And so we will take the bigger of those two, which is 90. So to calculate the projected ending inventory, we take 50 plus 250 minus 90, and that equals 210. All right, so now our projected ending inventory in week 17 is 210, and we are going to project the ending inventory into week 18. So now we're in week 17, looking into week 18. So the ending inventory we currently have is 210 plus the quantity that we have scheduled to produce, the master production schedule quantity for week 18, which is 0, minus the maximum of the booked orders or the forecasted demand. And we see here the bigger of those two numbers, between 60, forecasted demand, or 80, the booked orders, the bigger of the two numbers is 80. And so the projected ending inventory in week 18 is 130. Okay, why don't you try to calculate the projected ending inventory for week 19? So pause the video and then come back, press play, and I'll show you how to calculate it for week 19. So you give it a try. So we're projecting the projected ending inventory in week 19. It's currently week 18. Our ending inventory is 130. So we take 130 plus what we have scheduled, our production schedule for week 19, so plus 0, minus the maximum of the forecasted demand or the booked orders in week 19. So the bigger of those two numbers is 110. So 130 plus 0 minus 110 equals 20. So our projected ending inventory in week 19 is 20. All right, so now you pause the video and you try it for week 20. What is the projected ending inventory for week 20? So in week 19, we have 20. We will add to that the master production schedule for week 20, which is 100. And we will subtract the bigger of the two numbers, the bigger of the forecasted demand or the booked orders. And you can see here, forecasted demand is 110, booked orders is 80. We take the bigger of those two numbers. So the ending inventory in week 20 is 20 plus 100 minus 110, which equals 10. Now you try it for week 21. So this is our last one. You try it for week 21. Pause the video and see if you can get week 21 projected ending inventory. So we currently have 10 plus the master production schedule for the next week. So the master production schedule for 100, for week 21, which is 100, minus the larger of the two numbers, the forecasted demand or the booked orders. So the bigger number between 130 and 20. So the projected ending inventory for week 21 is 10 plus 100 minus 130, which is negative 20. Okay, so we've got all these numbers. Now let's take a look at that. In week 21, we have a projected ending inventory of negative 20. Is this a good thing? Well, no, that's not a good thing. That says that we're going to be 20 short in week 21. So this is why we do these calculations and why we project them out into the future. It's so that we can determine if there are problems with our production schedule. So at this point, we would have to figure out some other way of getting around it. So what we may have to do is, in supply chain, we are problem solvers. So I'll let you know that in our supply chain management program, we really view our students as problem solvers. Supply chain management professionals are problem solvers because there are difficulties and challenges that show up in business all the time. And it's the supply chain management people that have the skills to be able to figure out creatively solutions to these problems. So, here's a problem. We're going to be we're going to have 20 too few products available in week 21. We got to figure out a way around that. So, one thing we may do is we say, well, let's boost the production in, week 20 or week 21. Instead of producing 100, let's produce 120. That's certainly something that we may do in supply chain. But you know what? There may not be capacity. In other words, we may already be completely in our facility. We may be completely booked out where we are producing at the maximum that we possibly can. We might try to reduce the quantity that we produce of some other product so that we can increase the production of this particular product. We might decide to do overtime. So this is where we would get with someone that was in finance, for instance. This is a collaboration between supply chain and the other functions of the business. So we may collaborate with someone in finance and say, can we do overtime? Is overtime to get these 20 products produced? Is that good for us to be able to do? We might actually create a solution by collaborating with some of you who are in sales. So for instance, there in week 20, we have a booked order for 80 products, 80 of these products, and we may go to you in sales and say, hey, we don't have the capacity to produce all of the orders that we have. We're 20 short in week 21. Is there something that you can do? And you might go to your customer that booked the order for 80 there in week 20 and say to that customer, hey, I know you ordered 80, but do you really need all of those 80 there in week 20? And the customer may say, well, no, that was just a minimum order quantity, and so that's the number that we placed. And you may say, well, how many do you need in week 20? Can we ship you, 20 in week 20, and then 20 more in week 21, and 20 more in week 22? And what that will actually do is it'll give us some flexibility here in supply chain. So we're going to come up with solutions by collaborating with the various functions of the business and using our creativity to figure out solutions to these problems. So now we're going to do a calculation that we call available to promise. And available to promise, this is a tool that we create really for those of you who are in sales to help you when you're dealing with customers and collecting orders from customers. So there's two formulas here. You see the what those different variables are, and I'm going to walk you through how to use each one of these formulas. But what available to promise is, we're going to calculate available to promise for future weeks, and when we calculate available to promise, we're going to say to sales, we're going to say, in 2 weeks from now or 3 weeks from now, we have this quantity that is available to promise. And what that says to you in sales is, you can go out and sell that, because we've got the inventory. We're going to be producing these products. We're going to have them on hand, and so they will be available to send to customers. So feel free to go out and sell those products. And so that's what you're going to do in sales. You're going to go out and you're going to sell those products. If you get customer orders that are for more than the available to promise, then that's where you're going to need to collaborate with those of us in supply chain to figure out how to deliver that. Because if it's above the quantity available to promise, then we will not have that, or we potentially may not have those products in stock for those customers. And so we don't want to make promises. You in sales do not want to make promises to customers that our company can't keep in supply chain. So let's take a look at how we use these formulas. So here are the same numbers that we had on the slide previously. Notice that I have changed the master production schedule for week 21. I have that highlighted in red here so that we have a projected inventory, ending inventory of 0 in week 21. That way this production schedule doesn't have any problems. And we're going to be calculating available to promise. So it is currently week 16. Currently week 16, and we are going to be projecting first the available to promise in week 17. So it's currently week 16, and we are going to be calculating available to promise in week 17. Now, if you look at the previous slide mentioned that there are two formulas for available to promise. One of the formulas is for the first week, and the other formula is for subsequent weeks. So this is our first week here. We're sitting in week 16. We have actual real inventory. We have 50 on hand. So I'm looking at the shelves, at the inventory shelves, and I've got 50 of this product sitting on the shelves. So if we get customer orders for this, we can absolutely send those out. We actually really do have those 50 units in stock. So we're going to use this formula, this first formula for the first week available to promise. So here's how the formula works. Just reading across the formula, it's asking for ending inventory. So our ending inventory, week 16, is 50. That's the 50 that we actually have on our shelves, plus the quantity that we are going to be producing the following week. So the next week, we are going to be producing 250. Okay, so that's our production schedule. Now, so let's just pause here. So how many units do we have now? We have 50 plus 250, we have 300. Okay, so we have 300 units. Now let's look at, we're going to need to send those units out to real customers who have really booked orders. And this is why we've got this next term, which is the summation of booked orders. So let's look at what we're going to need to do. So we've got 300. We have booked orders in week 17 of 90. Okay, so we can ship, we're going to need to ship those 90. But then look forward, look to week 18. How many more are we going to be producing in week 18? Well, we're not going to be producing any in week 18. See, master production schedule 0. And look at week 19. Master production schedule is 0. Okay, so we will not produce in week 18. We will not produce in week 19. But look, we've got real booked orders. Real customers want us to send them product in week 18 and 19. So see that 80 and that 100? We still need to ship those orders. So we currently have 50. We're going to make 250 more. So we'll have 300. And out of those 300, we are going to need to ship all of the booked orders until we start producing again. And so this term summation of the booked orders from I equals T to Z minus 1, whatever that is, what that means is that we need to subtract out all of the booked orders until we produce again, until the master production schedule has us producing again. So for this first week, this week 17, that the available to promise is the 50 that we currently have, plus the 250 that we're going to make in week 17, plus, minus all of the booked orders until we produce again, because we're going to need to ship all of these booked orders based upon the quantity that we currently have. So that is 90 in week 17, the 80 in week 18, and then 100 in week 19. But then you see there in week 20, then we produce again. Okay, so we're going to have a master production schedule producing again. So we'll be able to produce and ship then in week 20 just fine. So here we have an available to promise of 30. Available to promise of 30. So here's how this formula works, available to promise. Now we're going to go to week 18 and do available to promise. Okay, so we say to sales, okay, sales, in week 17, you have available to promise, you have 30. And so if I tell someone in sales, and they're really good at doing sales, and I tell them, you can sell 30 more products next week, then what is the person in sales going to do? Well, they're going to go out and they're going to sell those 30. Okay, so this available to promise calculation, there's an assumption behind it. The assumption behind the formula is that if we tell sales that they have a certain quantity, in this case 30, available to promise, then they will actually go out and sell those 30. So if they sell those 30 in week 17, then how many will we have in stock? Then what will be our inventory? Well, then we'll have 0, right? Because sales is going to go out and sell them. This is why there's that second formula. So if you go back a slide or two where it showed the formulas, the formula that you see on this slide, This is the formula for the first week available to promise. And then there's a formula for all the subsequent weeks. And it looks like the same formula, except that it's missing the ending inventory term there. And the reason it's missing the ending inventory term is that in subsequent weeks, we are going to assume that sales is going to do their job so that we won't have any inventory. We're going to sell it all. So if we tell sales that we have 30 available to promise, then if we have 30 available to promise, then sales is going to go out and sell them. And so we're not going to have any inventory left. All right. So sales, we tell sales you have available to promise 17 or 30 in week 17. So in week 18 and week 19, we're not producing anymore. And those booked orders are taken care of by the 50 that we originally had plus the 250 that we made in week 17. So we do not have any more available to promise until we produce again. So anytime you have a master production schedule quantity that is 0, you will not have available to promise. So there's no available to promise in week 18, and there's no available to promise in week 19. But now let's look at week 20. Well, let's calculate the available to promise. So notice here, we're now standing in week 19. We're going to assume that sales has sold all of our inventory. So we have 0 in inventory. And now we're just going to say, well, how many are we going to make and how many are we going to sell? So in week 20, master production schedule, we are going to make 100. And sales has already collected booked orders for 80. And so the available to promise is 100 minus 80, which is 20. So keep in mind now, we're going to tell sales, okay, sales, in week 20, you've got 20 available to promise. You can actually sell 20 additional products in week 20. And so the assumption behind this formula is that sales is going to do a great job of doing their job, and they're going to take those 20 and they're going to go out and sell them. All right, so we're going to make 100. We're talking about in week 20. We're going to make 100. We have already sold 80 of those. So we'll ship those out, and we're telling sales, hey, sales, you can sell another 20. And so sales is going to go sell those 20. All right, so now we're going to have 0 inventory again. So now let's go to week 21. So in week 21, master production schedule, we're going to make another 120. And we already have booked orders for 20. And so the available to promise, the quantity that is available for sales to promise to customers is 120 minus 20, which is 100. And so there's 100 available to promise for sales in week 21. So here are the final available to promise numbers. All right, let's do a couple of more examples to make sure that you understand how these formulas work. Okay, now this is the same set of numbers, but I've changed the master production schedule there in week 20. You see that? I've changed it to 0. So now we're not going to be producing this particular product in week 20. Keep in mind, just as a reminder, this doesn't mean that our plant is shut down or that our factory is idle. We're producing products. But this particular product we are not producing in week 18, 19, or 20. The plant will be making one of the other thousands of different products that that our company produces. So let's calculate the available to promise now in week 17 if this change has occurred here. All right, so let's redo this calculation. This is our very first week. Remember, we're sitting in week 16 currently. We actually have a real 50 units sitting on the shelf that we can sell. And then we're going to be producing 250 in week 17. We will not produce again until week 21. Why don't you pause the video, see if you can do this. How would you calculate available to promise now in week 17? So pause the video and then come back and I'll walk you through how that calculation is done. All right, so we're going to use this formula. So here's the formula. Available to promise equals the ending inventory that we actually really do have in this current week plus the master production schedule that we will be producing for that next week, minus, and here's what this summation sign means, it's minus all of the booked orders until we produce again. All the booked orders until we produce again. So we currently have 50 on hand. We're going to make 250 more. So we'll have 300 then that we can sell. And we won't produce any more of this particular product until week 21. So that 300 has to last us until we produce again. It has to last us for week 17, 18, 19, and 20. And we have booked orders for all of those weeks. So that 300 has to be able, we have to be able to ship those 300 to fulfill the booked orders of 90 in week 17, of 80 in week 18, of 100 in week 19, and of the 80 in week 20. So the formula goes, it's 50 plus 250 minus the sum of 90, 80, 100, and 80, and that is negative 50, which of course is a problem because now we do not have enough. The sales, we're telling sales, you have negative 50 available to promise. You've already sold 50 too many, is essentially what we're saying to sales. So this is a problem, and of course we would use our problem solving skills in supply chain management to overcome this problem, either working the problem from a manufacturing and supply chain standpoint to increase production to take care of those 50, or working with sales to work with the customer to delay some of these shipments so that we have time to be able to produce them. So we would figure that out with sales. All right, let's do another example. So for this set of data, I'd like for you to calculate the available to promise in week 17 and then calculate the available to promise in week 18. So recall, we're currently standing in week 16. So when we project available to promise in week 17, you're going to use that first formula, that formula that's there on the left. But then once we move to subsequent weeks, so once you go to week 18, we're going to use the available to promise formula on the right because we are going to assume that sales will actually sell any quantity that we calculate for available to promise. All right, so you pause the video and then I'll come back and we'll walk through these calculations together. All right, so let's calculate available to promise for week 17. So we're going to use the formula there on the left, and the formula goes, we take our actual ending inventory, the actual inventory that really is physically sitting on the shelf there in week 16, that's 50. And then we will add to it our master production schedule for week 17, 250. Minus all the booked orders until we produce again. Well, we're going to be producing there in week 18. So out of all of that inventory that we create, we only have to send out the 90 booked orders that we have there. So it would be 50 plus 250 minus 90, which equals 210. Now, some students may say, well, why don't we use, the projected ending inventory in week 17, 18, 19 in these formulas? Why don't we use those projected ending inventory numbers? Remember, those are projected ending inventories. That is a prediction of our ending inventory. It's not our actual ending inventory. So the only actual ending inventory we have is in our current week. It's the actual inventory that we can see on the shelves, and that is the 50. All those others ending inventory are just projections. They're not real inventory that's actually sitting on the shelves. And so here we are, we're in week 17. We have 210 available to promise. And so when we tell sales, hey, there's 210 available to promise for you, sales is going to go out and actually sell those 210. That's the assumption behind this available to promise formula. Okay, so you pause the video and see if you can find the available to promise for week 18. So now we're going to use the formula there on the right, the available to promise formula that's listed there on the upper right of this slide. We are assuming that sales has sold the 210 that we had available to promise in week 17, and we're calculating the available to promise in week 18. So the available to promise in week 18 is the master production schedule for week 18, which is 100, minus all of the booked orders until we produce again. Well, we're not going to be producing in week 19, but we will in week 20. So this 100 that we produce in week 18 has to be able to cover the booked orders from week 18 and the booked orders from week 19. So the available to promise is 100 minus the sum of 80 and 100. Which is negative 80. And of course, this is a problem, so we would have to go into problem solving mode again and figure out a way around this. Now, there are lots more practice problems in the practice problems section of Blackboard. I'm going to encourage you to go to the practice problems section and try these calculations out for yourself. You can use these formulas when you're solving those problems. Any of the formulas that are shown on the review sheet, the formulas shown on the review sheet, the pictures of those formulas are going to be the same pictures that will be available to you during the exams. So now let's discuss what is involved in the calculation for material requirements planning, or MRP. So as a reminder, when we calculate MRP, which in software systems that we use to manage our scheduling in our companies, these are called enterprise resource planning software packages, ERP systems. There is a module within those that is called MRP, material requirements planning. It simply involves pressing a button and the software will do all of these MRP calculations for every single one of our products simultaneously. Now, we're going to be dealing with just one component or one product at a time here in these calculations in this class. It's important that you understand what goes into these calculations so that you can, when you get into our supply chain management classes, you can better understand what the output of these software systems really is giving you. So remember, when we calculate MRP, when we press that button and do the calculation for MRP, it's going to inform us of two things. It's going to tell us how many more raw materials do we need to purchase, and it's going to tell us how many more products do we need to produce. So it's going to give us information about what our production should be, as well as what our procurement should be. And so here are some terms that we use when we talk about MRP. So the first one is independent demand. So independent demand, typically we think of independent demand as being finished goods demand. It's the demand that comes from our customer for finished products. So just to try to give you an idea of how this works, let's imagine that we are a company that is making bicycles, that is producing bicycles. So the independent demand will be the demand that customers have for bicycles. So customers want to buy, we have a forecast that customers are going to be buying 100 bicycles. We'll have 100 orders for bicycles. 100 bicycles would be our independent demand. Next, we have dependent demand. So I think of this dependent demand. This is the demand that depends on the independent demand. So in this case, dependent demand is the demand for all the raw materials or all the components that go into building the independent demand. So, if we have a bicycle, for instance, a bicycle has 2 wheels. So if we have independent demand for 100 bicycles, then we will have the dependent demand of 200 wheels, because we need those wheels to build those bicycles. So every product that we have has, you can think of it as a recipe. It is a list of components or a list of assemblies, sub-assemblies that go into producing that. And those are listed, those are described in something that's called the bill of materials. So the bill of materials is the list of all the dependent demand items that are used to create one unit of independent demand. So for instance, for a bicycle, we might have one bicycle, and the bill of materials for a bicycle would be 2 wheels, 1 seat, 2 sets of brakes, 1 chassis, and then even the wheels would have a bill of materials. So, you would have a bicycle. One bicycle has 2 wheels in the bill of materials, but each wheel contains, 1 rim, 1 inner tube, 1 rubber tread, 1 valve stem, 36 spokes, and so each wheel will also have its bill of materials. So you have this indented product tree structure. It typically looks kind of like an outline where you have different levels of detail as you dive deeper and deeper to figure out what the different components are in dependent demand that go into building the independent demand item. Now, when MRP does its calculation, it performs a procedure that is called exploding the bill of material. Now, exploding the bill of material sounds like a bad thing. Exploding the bill of material is not a bad thing. It is just taking that bill of material and separating out all of the separate components that go into it. So here you have a picture of a bicycle, and this is actually called an exploded view. And it shows all of the different components that would be involved in that bill of material. So material requirements planning, again, will calculate the need for production as well as the need for raw materials, and it's going to schedule when all of these activities need to happen in order for the independent demand product, whatever that is, to be completed on time. So we're going to have a planning lead time. So the planning lead time is from when the customer places or when a component is ordered until it arrives, and we're going to use backwards scheduling to predict when we should place orders for raw materials to get these items on time. So as an example, let's say that we have a retail outlet that they know that they're going to need a bicycle. And so they need a bicycle and they need to order it. Now we're going to do backwards scheduling to get that bicycle there on time. So we know that there's a shipping time to get from the distribution center to the retailer. We know that there is a lead time to get from the manufacturer to the distribution center. We know that there is a lead time for actually assembling the bicycle. And then we know that there's a lead time to get the raw material or the component parts from a supplier to the manufacturer. And so we add all of those times together to determine when should we place an order for raw materials in order to get that raw material at our facility in time to produce the item, in time to deliver it and get it to the customer on time. And so this is all calculation work that MRP does. Now, our students use MRP systems or use enterprise resource planning systems within the class SCM 4380 ERP. So I wanted you to know a little bit about what that class is about.
My name is Dr. Miller, and I am one of the professors who teach SCM 4380 Enterprise Resource Planning. Now, Enterprise Resource Planning, or ERP systems, are the principal means by which complex and global organizations integrate and manage their business processes. These systems involve utilizing specialized software to coordinate activities across the supply chain. So within an organization, ERP systems will allow a company to do forecasting or help facilitate forecasting, exploding the bill of materials, running MRP, purchasing components through suppliers and raw materials from suppliers, scheduling and initiating production, tracking inventories, tracking sales, reporting data that is used to manage the business. Within an enterprise, so for larger companies, where there are several company entities scattered globally, a parent organization can view and control all of these functions from a central location through an ERP system. And beyond that, within the supply chain, ERP systems are really starting to be used by companies to gain visibility across the supply chain, to gain visibility across Tier 1, Tier 2 customers and suppliers. Companies within a particular industry will have the same ERP system or compatible ERP systems. They'll be able to communicate with one another or talk with one another and transfer information back and forth between them. So in this class, you will gain a basic understanding of ERP systems, their functions, and their current applications in practice. You will learn how ERP systems evolved, how they work, and some of the issues involved in successfully implementing them. Now, one of the really fun and exciting features about this class is a semester-long simulation that you'll participate in, where within a team, you'll have a team of typically 4 students. You'll be running a simulated company. You'll be managing a cereal manufacturer in a live competition with other teams in the class, and the simulation lasts all semester long. During the simulation, you will get to design your own product portfolio. So you'll get to designate the bill of materials. You'll determine what ingredients are going to be in your different cereal products that you offer, what quantities of products or what quantities of raw materials will be in there. So how much of the wheat and oats and nuts and different fruit products would you like to put in your cereal to make it a competitive product or make it a desirable product for your customer base. You will get to purchase your own production equipment and specify production capabilities for that equipment. You will forecast raw material prices and sales. So you sort of look into the future and determine what do the prices look like, what do sales look like for each of our products within each one of different regions, within different customer groups that you might have to manage, and establish pricing for your different products and marketing for your product. You will manage the purchase of the raw materials, schedule production, manage sales, and marketing. So one feature that I think really makes this exciting is that we do not use some education version of ERP software or a textbook version of ERP software. We actually use the most popular ERP software that's on the market. It's SAP. It has about a 25% market share of ERP systems. So the likelihood that you'll be using SAP somewhere in your career, regardless of your major, is actually pretty high. So during the simulation, you'll evaluate the performance of your company using management dashboards, graphs, charts, all different things that you either create or that you configure within SAP. And you'll create them or analyze them using Excel. So a few of the benefits to your career from taking this class, well, the first one is that you get to learn and use SAP. So this really popular software will be beneficial to you when you are in industry because it's not a simplified version that we use in class of the software. It's really the full-blown SAP software. You will already know the basic navigation within the software when you start working for a company, and because SAP is the most popular software, even if you work at a company that doesn't have SAP, it's likely that their ERP system has been modeled off of SAP, and so it probably works somewhat similarly. You'll also learn to use Excel to do meaningful business data analytics. This is a skill that companies are looking for in job candidates. This is really one of the features of many of our classes in supply chain, but we definitely use this here where we integrate a lot of your skills from business modeling and some of the other supply chain classes that you've had to be able to do business analytics, and then that becomes very powerful for the students as they're looking for jobs and starting out in their careers. You'll also gain experience in adjusting supply chain variables that have a real impact on company performance. So as a result of participating in the simulation, most of our students are able to include very strong wording in their resumes describing how they were able to drive measurable business performance improvements in a competitive environment. It's something that they can actually justify and measure. So every semester, I also have previous students that will contact me saying that the experiences that they learned in this class have helped them in their careers. Whether their company's using SAP and they entered a new job, they were able to be competent or productive in their company because they knew SAP, or their company has put them in charge of choosing or implementing an ERP system and they felt knowledgeable to make good decisions, or that the class gave them experience in driving the performance of a team in a team environment, in a competitive environment, and students report that the learnings that they get in this class are benefiting their careers. So those of you that are supply chain majors, this is one of those classes that will also give you the opportunity to earn a couple of certificates. This is a requirement for both the strategic sourcing and the analytics certificates. So I look forward to seeing many of you in this class.
So these are the simplified material requirements planning calculations that we're going to be using for this class. These are not calculations that are included in the textbook. They are calculations that will prepare you to be successful in SCM 4380. They really are pretty simple. You see all the definitions of the variables in the formulas, and I think the easiest way to understand how to use these formulas is just to use them in a real example. So let's take a look. So MRP tells us how many we need to make and how many we need to buy. So this first calculation is how many we need to make. We're going to be calculating future planned production orders, which is an order to produce in our factory. So here's how the formula works. It's the maximum of either 0 or the forecast minus finished goods you have on hand minus any production that you've already released. Released production means production that you are currently actually producing. It's in line to be able to be produced on the machines already scheduled or already being in the middle of being produced. So let's look at this formula should seem pretty direct. Let's think through a pretty simple example that you could probably relate to. All right, so you'll want to write these numbers down. So let's say that you expect that you're going to need 10 eggs. So you've got a family in the house and you're cooking breakfast, and you know I'm going to need to cook 10 eggs altogether. So 10 eggs, that's your forecast. Let's say that you've already made 4 eggs. You've already cooked 4 eggs. That's your finished goods inventory that you have on hand. So you expect that you're going to need 10. You've already made 4. And let's say that you look in your pan and you have 2 eggs in the pan right now. So that 2 eggs, that is your released production. So what this first formula says is, how many more do you need to make? You're going to need 10. You've made 4. And you're currently in the middle of making 2. So you're going to need to make 4 more. And that's all this formula says. So here we've got numbers here for booked orders, for forecasts, for finished goods, products in inventory, and for released production for 2 products, product A and product B. And we are going to calculate for each of these products, product A and product B, our future planned production orders. So let's follow the formula for each of these products. First, for product A. For product A, our future planned production order will be the forecast for product A, which is 125, minus the finished goods we have in inventory, which is 80, minus the released production for product A, which is 50. So 125 minus 80 minus 50 equals -5. And what this says is we already have more products than we need. We already have on hand, plus what we're going to be producing is more than what we need. So we do not need to produce any more. There's no additional production that we need to release for product A. For product B, our forecast is 250 for product B, minus 150 in finished goods, minus 50 that we currently have in production. So 250 minus 150 minus 50 equals 50. So we still have 50 outstanding that we need to produce. So that's an additional 50 that we're going to need to plan in production. All right, so now let's calculate how many raw materials we need to order. So this formula calculates additional purchase orders for raw materials that we need. So we're going to be doing production. We need raw materials in order to produce those products. And we need to know how many purchase orders for raw materials are we going to need to submit. So the new purchase orders for raw materials will equal the maximum of 0 or the planned production orders. So this is how many we're going to be producing. We need to produce the planned production orders. We're going to need raw materials to do that. We have raw materials that are available, and we have scheduled receipts. So scheduled receipts, that is orders for raw materials that we have placed in the past that have not arrived yet. So this is like when you place an order on Amazon and you haven't received that item yet, but it is on its way. So this is raw materials that we do not currently have, but that have been ordered and are on their way. So we have planned production orders minus raw materials that we currently have available, minus any raw material orders that we've already placed. And MRP is going to tell us, do we need to place any additional raw material orders? Okay, so let's see how this looks for our product C and product D here in this example. So first, let's look at product C. So it says here that we have currently planned production orders for 75 of product C. In other words, we want to produce 75 product Cs. So new purchase orders will equals the maximum of 0 minus, let's do the calculation, planned production orders for product C, 75, minus the raw materials that we have available. We currently have enough raw materials to make 25 of product C, so minus 25, minus any purchase orders for raw materials that we already have submitted. They're on their way. We haven't yet received them. And it says here that we have placed an order for 75 enough raw materials to produce 75 product Cs. It has not yet been arrived from the supplier, but it is on its way. It's already been ordered. So 75 minus 25 minus 75 equals negative 25. That means that after this purchase order for raw materials that has already been submitted, after those raw materials arrive, we're going to have more raw materials than we need. We're going to have actually enough 25 for 25 additional product Cs, and we aren't even planning to produce those, so we do not need to create any new purchase orders. Let's look at product D. Same calculation. We are planning to produce 200 more product Ds, minus we have raw materials to produce 25 product Ds, and minus 75, we have placed orders with a supplier for enough raw materials to build 75 product Ds. So we need to make 200. We have enough raw materials to produce 25 currently. We're going to be receiving another 75 products worth of raw materials from our supplier. So 200 minus 25 minus 75 gives us a deficit of 100. So we're going to need to place new purchase orders for raw materials in order to build 100 more product Ds. So there are several advantages to using MRP. In complex production environments where the scheduling is complex and where the products are complex, MRP gives us some advantages in being able to coordinate all of that complex scheduling. It's automated using software systems, so it enables us to trace what is happening in our organization and help us understand what we need to do to be able to meet our customer needs, to build the products that we need to create that value for the customer. Because it is in software systems, this enables us to be able to use that information to help communicate with suppliers, to be able to communicate with various parts of our own business, and to coordinate the activities that need to happen inside of our company. There are some special considerations that companies need to keep in mind when using MRP. One is that just like any software system, it requires accurate information to be inside the system, accurate information about inventory quantities, about production rates, and this requires a lot of maintenance to keep those things up to date. MRP also has to deal with uncertainty. So there's variability in production rates, there's variability in quality, variability in demand rates, and variability in performance of suppliers and when orders arrive. And so MRP, it's important for people that are using MRP to understand that there's actually variability in a lot of the numbers that are inside of MRP. This creates something that is called MRP nervousness. So here's a definition of a term. MRP nervousness, it's a term that refers to the fact that when very small changes happen in a schedule, or when very small changes happen in a bill of materials, then it can have a wide impact on the organization. Even just a small change in a bill of materials or small change in demand can have a big ripple effect throughout our organization. And MRP reflects this in the calculations that are made. So we have to maintain that maintenance of that system in order for all of this to remain accurate. All right, so that's it for today's video lecture, and next time we're going to be talking about Lean and Six Sigma.